Hello all, I am Disha, an electronics and communication student at Sri Venkateshwara College of Engineering. I am here to give a presentation on Fourier Transform and its properties. What is Fourier Transform? Fourier Transform is a mathematical model which helps to transform the signals between two different domains, such as transforming signal from frequency domain to time domain or vice versa. Why we have to convert the signals from frequency domain to the time domain? Because the analyzation of the signal in the frequency domain is most flexible as compared to the time domain. Again, the question arises, why only Fourier transform? Why not Fourier series? Because Fourier series is only applied to the periodic signals but not non-periodic signal. In order to convert non-periodic signals into the frequency domain or the time domain, we need to use Fourier transform, which is more flexible. There are 10 properties in the Fourier transform. They are linearity, time shift, frequency shift, scaling, frequency differentiation, time differentiation, convolution, integration, modulation, Parseval's theorem. Let us consider the first property, linearity property. Consider x of t as the first signal and apply the Fourier transform. We get x of omega as shown here. Consider another signal y of t and apply the Fourier transform. We get y of omega. Linearity property states that the sum of two signals, when the Fourier transform is applied to the sum of these two signals, we get the respective sum of individually performed Fourier transform of the signal as shown here. In the proof of linearity property, z of t is considered as the sum of the two signals x of t and y of t. In the proof, I have just applied the Fourier transform to the z of t and I have substituted z of t as the ax of t plus by of t, where a and b are constant. As we can see the proof, z of omega is ax of omega plus by of omega. Consider another property as time shift property. The time shift in the signals can be done either right side or left side. Here I have considered a time shift at the right side, that is x of t minus t naught. When the Fourier transform is applied to the signal x of t minus t naught, we get the result as e to the power minus j omega t naught into x of omega. In the proof, I have considered x of t minus t naught as y of t and later I have substituted and proved the equation and I have got the answer as e to the power minus j omega t naught into x of omega. This is the proof of time shift property. Moving on to the next slide. Consider another property, frequency shift property. In the frequency shift property, the shift is made in the frequency domain. As we see here, x of omega minus omega naught, which is the frequency shift. Consider a signal e to the power j omega naught t into x of t. Apply the Fourier transform to this signal, which in order we get the output as x of omega minus omega naught. In the proof, I have considered y of t is equal to e to the power j beta t into x of t, whereas beta is omega naught. By applying the Fourier transform to this signal, I have got the output as x of omega minus beta, where further beta is substituted as omega naught. Moving on to the next slide. Another property is scaling property. In the before slide, we have seen the linearity property where the constant was multiplied to the signal, like a into x of t. But in scaling property, we have multiplied the constant to the t, which is time. It's like x of at. Apply the Fourier transform to the signal x of at. We get the answer or the output as 1 by a into x of omega by a, as shown here. Now consider the scaling properties proof. Here I have substituted x of at by y of t, and by applying the Fourier transform of x of at, by having the condition a should be greater than 0 and substituting a of t to the constant lambda, you may consider any constant. And by applying some differentiation properties and integration properties, I have got my answer and proved it. My output is 1 by a x of omega by a, which is matching to my RHS. Moving on to the next slide. Considering the another property, frequency differentiation property, where we consider the input as minus jt x of t as the input signal, and applying the Fourier transform to this signal, we get differentiation of x of omega with respect to the omega. The proof of frequency differentiation property is shown here. Moving on to the next property, time differentiation property. Have considered input as differentiation of x of t with respect to t, and by applying the Fourier transform to this signal, have got the output as j omega x of omega. Further, the proof is shown here. Convolution property, I have considered two signals, that is x of t and y of t. Applying Fourier transform to these signals, I have got x of omega and y of omega respectively, and I have considered z of t as convolution of x of t and y of t. By applying Fourier transform to this z of t, I have got the product of x of omega and y of omega as shown here, and the proof is shown below. Another property is integration property. Here my input signal is integrated, and by applying the Fourier transform to this integrated signal, I have got the output as 1 by j omega into x of omega. Modulation property. Modulation property is also called as multiplication property, where I have considered two signals x of t and y of t, and by applying the Fourier transform of these signals I have got x of omega and y of omega respectively. I have considered z of t as the product of x of t and y of t, and applying the Fourier transform to the z of t, I have got the signal in the frequency domain, that is 1 by 2 pi into x of omega convolution with y of omega. The last property is Parseval's theorem, which is also called as Rayleigh's theorem, where E is the total energy content of the signal x of t. Also, x of omega to the power 2 is defined as the energy density spectrum of the signal x of t. The proof of the Parseval's theorem is shown below, and this Parseval's theorem is also called as energy theorem. Thank you for watching my video. Please like, share and subscribe.